All right. How was lunch? Cool. I hope you learned something so far. So I'll be talking about introducing bounded context in a monolithic application. So imagine you have this new project. You can start all over again, greenfield, but you need to deliver value to your customers as fast as possible. So you get your squad together, start coding, grab your favorite MVC framework, and you start building. And everything is fine. You deliver your first features, customers are happy, great. But as with all successful projects, there's more complexity, more features to be added, more team members to onboard, more developers working on the same application. And you notice that, well, productivity starts to drop a bit. Still, it's not that big of a deal, so you can continue. But this complexity in your project keeps growing and growing and growing. And with that, your productivity actually starts to decline. And at some point, your productivity starts to decline exponentially. And your complexity just increases with it. And this is where most people actually have a really bad experience with monoliths. Because I think everyone has this one project in mind where they're like, I can't do anything in there. So what exactly happens when a monolith scales in complexity? First of all, it's really hard to get the mental model in your head for the whole application. So it's a really high cognitive load when you're developing. And we developers, we try to be lazy, so I don't want to think too much. But with a monolithic application, I actually have to really understand everything in order to do something. Next to that, it's more difficult to predict the impact of the changes. And you find this through like your planning sessions, where you actually see like, yeah, it can be anything between maybe 2 days of work or 2 months of work. I don't know what's hidden under the carpet. Next, it's really hard to onboard new engineers. And I guess that everyone has the experience. It's the first day on the job. You're really excited to get started on this new job. You open your laptop, download the source code. Now what? I don't know where to start. Everything is intertwined. How can I be productive in this? And last but not least, implicit expertise. So what do I mean by this? It's not really clear who knows everything about a certain aspect of your application. And when you are planning a new feature, you might actually overhear some colleagues saying like, oh, you should talk to this person. He knows everything about it. But because there are no clear boundaries, it's really hard to actually know who is responsible for what. So this is a problem. And we developers love problem solving. So you start searching for answers. And you stumble upon this DDD thing, and you might see somewhere that you need to introduce boundaries in your project. And that's actually bounded context. Split your application up into smaller parts. Make a big problem, make it all smaller problems. So what is a bounded context? First of all, it's independent and loosely coupled. Of course, your components need to talk to each other, because if they don't talk, well, then you have just 2 different set of systems. So they need some way of communicating, but you want to have them not communicating a lot, but just a bit. And they need to be independent. They don't need to rely on another component. Next, each bounded context has its own ubiquitous language. And we'll dive into that a bit further on in the talk. And each context has its own data. And that's also really important. And last but not least, contexts have an explicit owner. You can dedicate a person or a team to a context and tell them you are now responsible for that thing. And because you have some clear boundaries, now it's really doable to actually appoint someone to that. So what do I mean with loosely coupling? On the left, you might see strongly coupled context. They actually really depend on each other, and they have a lot of communication going on between them. And it just turns out spaghetti, and you might actually want to merge them because apparently they are the same thing. On the right, you see a better example of loosely coupling. Yes, there is some communication happening between the two, but it's really, really loosely. And you can actually use context B without context A, and maybe you can also use context B or context A for like most of the time without needing context B. Next, ubiquitous language. And this slide I actually stole from Cyril, who gave a great presentation a few years back on DDD about bounded context. And to explain what is ubiquitous language, let's look at an example. At Amazon, what do you think is a book? And it really depends on what department you ask. Because the catalog was responsible for marketing and displaying the products. They care about the picture of a book, who's the author, maybe a short title, a description, a rating, all that kind of stuff. But do you think they care about that in the warehouse? No. With shipping, they just care about how big is it, how heavy is it, does it fit in the box? Yes, okay, we can ship it. For the shopping cart, that's not important at all. It's just how much is it? That's the only thing you need to know in your shopping cart. So as you see, if you look through different lenses, a book can be a different thing. And this is a great heuristic to actually find your bounded context. Next, let's look at sharing data. So this is really bad because it's actually an implicit contract between two services if they use the same data. And as we saw 2 slides back with the chatty contexts, SQL is actually a contract as well. And if you say, here's the table, you can do everything you can do with SQL with that data, then your contract is just like infinity. You can do everything with the data. So how are you going to enforce that contract? You can't. So each context has to have its own data, and it needs to guard that. So you might actually think already, oh, I know what you're talking about. That's just microservices. And well, you're not wrong, but it's not the only silver bullet to actually introduce bounded context. And let me take you guys back to the first job I did. It was at this really small startup. It was started with 2 founders and 1 developer. And he had some investors, and the investors gave some great advice. Start with microservices, because that's the next big thing. And well, when they demoed the application, this was actually the first screen I saw. It was a really nicely rendered error page with some random Giphy pulled in of something failing. And what was happening behind the scenes were a dozen of microservices that all were really chattery, and this one developer had never actually worked with microservices, and just it was an unreliable software. So I'm not hating microservices. Microservices are really great, but only in large organizations. Only when you have the resources, the know-how, the skills, and the time to develop your microservice landscape, then it's a great technique. But most small to medium to even some smaller large organizations don't have the knowledge in-house or don't have the time to commit to make your microservices really, really great. So first of all, microservices have a really high upfront design cost. You need to find your boundaries, and you need to find how they communicate with each other. And if your design is off, then you're in a lot of trouble, because now you have like really chatty microservices, and you're not agile anymore. So next to that, consistency and reliance with microservices. It is all solvable, but it adds a lot of complexity to your project. So next thing, changing boundaries is expensive. If you discover that your boundaries are wrong with microservices, you now need to move components from one code base to another. You need to introduce new communication patterns. You need to make a new design. So there's a lot of time actually spent in refactoring to the right boundaries, if that's even possible at all. So if you look again at the graph of productivity versus complexity, you'll see with microservices you have a really slow start because you need to make sure your boundaries are right. Then your productivity starts to rise again, but then you discover, hey, this new feature actually requires data from all the different microservices we have. So shit, our boundaries are wrong. So what now? Now what? So you need to refactor, your productivity drops, but after the refactor, your productivity gets up again at a steady level. So with most big organizations, this actually is acceptable and a great way. But if you want to validate your ID fast, then it's not that great. So that leads us to the question, can we introduce boundaries in a monolith? And I wouldn't be standing here if the answer to this question was no, so luckily we can. So first of all, we need to look at how can we actually communicate between bounded contexts that are in the same monolith. And there are 2 patterns for this. One is messaging, and the other one is direct calls using well-defined interfaces or contracts. And you might actually see a really big similarity between these communication patterns and the communication patterns you see between microservices. Because microservices, you can also have them communicating through events and messages, and their direct HTTP calls are actually the same as direct calls using interfaces. So let's look at messages. So messages can be put on an event or command bus, and most frameworks will actually provide something like this out of the box. They are actually really loose coupling, since the consuming context of an event only needs to know the schema of the event. That's all it needs to know. It doesn't care about where it's coming from, how it's triggered. It doesn't care. It just needs to know this event will appear sometime, and I can do stuff with it. And next, you want to actually store your messages somewhere. This is not actually a requirement, but it will make your life really easy in the future. Because imagine if you need to introduce a new context to your system, and it needs to build some state based on the history of messages. If you don't persist them, you need to do some complex migration. You need to recalculate, like, what should the state be, and then you need to be precise on, like, when does it pick up events, and it's a nightmare. But if you actually have your history of messages, you can just ask, like, OK, what's the first message? Cool. And then you can process it. OK, what's the next one? You keep processing it until you're in sync with the stream, and you can deploy your new context. You also want to try to handle them asynchronously. You can imagine what happens if everything happens in sync, and there's a lot of stuff reacting to one event. Then suddenly your system gets starting slower and slower and slower. So where you can, try to handle them asynchronously. But there are some shortcuts we can take, and sometimes we can close our eyes and handle the sync just if it makes your life easier, and you refactor that later on. So let's look at some code examples. And I have to warn you, it's PHP, but it's not that bad anymore. And if you squint your eyes, it just looks like Java, so it will be fine. So we have this order placed event, and it has some simple properties on it. Some properties that actually allow the consumer to do its thing, to know what the event is about. Next, we can publish this event on a message bus. So we inject the message bus in our order service, call publish on it with our event, and everything is great. That's the only thing the providing context needs to do. Now let's look at the consuming context. So we can handle the event, and we can do our thing we need to do. So we can ship the goods if it's a physical order, or I don't know what. It's not my problem, but all the consuming context can just do their thing. Now let's look at direct calls using well-defined interfaces. So this is the alternative for microservice to microservice HTTP calls. They are synchronous. You get your result back if the order context is up. If not, then you have a hard time. So the providing context exposes an interface. And this interface tells the consuming context what are the available methods and what are the expected return types. And next, the consuming context only needs to know about that interface. And it doesn't need to know about any implementation details. Those will be provided on runtime by your dependency injection. So if you look at code examples for this, we can see we have a public user repository. And maybe if I listen to the previous talk, I should rename this to something else. Maybe, yeah, I don't know what. But this naming is probably wrong. So we have a public user repository, and we can get a user by its ID. And we also specify the object we get back and the stuff we can do with it. So this returned a public user has two methods on it: give me the name and give me the age. Now the providing context can implement this, and maybe it does some SQL query or I don't know what, and it will give you the user back. And the consuming context only knows about the contract, only knows about the interface. It expects the type back, and it can do stuff with it. Nice thing of this is that our tests of the consuming context also don't care about the implementation in the providing context. So we can make a stub or a test mock against the contract. We can provide that in our tests, and everything works without needing the other context. So this is all great, but how can we introduce that in an already existing monolith? And there's actually a few easy steps you can follow. First of all, create a context map. You need to have a good design before you start coding. So this is really important. Next, you can just move the classes to the context they belong to. And most IDEs will actually help you with that. It just like select a class, or select maybe even a directory, drag it to your new context, and your IDE will do the refactoring for you. And everywhere where the class is used, it will now change the namespace. After that, you need to be able to detect where a context uses or depends on a class of another context. Because we don't want that. That's like really strict coupling, and we want to remove that. So you're going to introduce some static code analytics that tells you, hey, this context knows a lot about this other context, so you need to look at that. After that, you can refactor to use the communication patterns we just discussed. So you introduce your messages, your commands, and maybe your direct calls. So what is a context map? A context map is the result of some collaborative workshopping you do with your team. And in the end, it will give you a map of the context you have in the system and how they depend and interact with each other. This also really applies to your team structure as well. So I don't have too much time to explain context mapping, but if you have a time machine, you can actually travel back to the previous session this morning by Michael, who gave a great presentation on it. Or you can look it up on YouTube. It will be available. So that's the first step. We now have a context map, but we have this monolith looking like this. Yellow are classes belonging to one context, and green are classes belonging to another context. And as you see, it's just one big ball of spaghetti, and everything is depending on each other. And yeah, we can't really develop in this. So remember our first step. Let's move green to green and yellow to yellow. Let's move the classes to the context they belong to. And it now looks like this. And this is already way better. Like stuff that changes together, lives together. And there are some dependencies, but this already is a great improvement. And nowadays, with your IDE support, it's a refactor of a few hours, maybe a few days. It's quite a good first step to do. So now we have this. Now let's look at our static code analytics. So with PHP, you have PHP stand, and there are all kind of alternatives for this, for other languages. And we can measure two things. First one is cross-context code usage. So this is when context A requires a class from context B to actually operate. Next, we can measure is actually how much coupling is there between a context using our communication patterns. So how much events are required from context A, how much direct calls are going from context A to context B. We can measure those things and have some great insights about that. So in our example, those two red arrows are the problems we have. Like context A requires this class from context B, and context B requires this class from context A. So our static code analytics detects this, and we can make this some kind of priority for the team. Like, hey, over the next few months, we want this coupling, we want it down by so much %, or we want to have no coupling at the end of the year. You can set really, really good targets for that. So the team gets working, and they introduce some direct HTTP call or some direct calls using an interface, and they introduce a message bus to communicate to that, and they resolve the direct code calls. So I told also that you can measure your amount of coupling. So in this example, you can see that context A makes a call to context B, and there are some messages going back and forth between context A and context C. And there's also one message going back and forth between context A and D. And there aren't really specific targets you can set to this. You can't just tell, like, we don't want more coupling than X% or something. But it can be a really good indicator that your boundaries are right or wrong. So if you see that your boundaries or the communication between two contexts is like a lot, or there's one context in the middle that all the other contexts depends on, that's a sign that maybe you need to look at your communication patterns. So this is all great. what are the advantages of a modular monolith? First of all, it gives you the boundaries in a monolith without the disadvantages you have with your microservice system. So you don't have to add the complexity for your reliance, for your DevOps, stuff like that. No, you can get the boundaries without the rest of it. Next, it's way easier to refactor your boundaries. Imagine down the line of the project, you actually discover that your boundary design isn't right. You can now redesign it and apply these steps we just discussed. So you make this new context, move classes over to there. Maybe you even temporarily allow some coupling because, well, we're in the middle of a refactor. And now you can, commit by commit, remove the dependencies on each other and introduce the communication patterns. So this is a way more granular way of refactoring than you'd see with microservices. It also is way easier to work in and set up as a developer. When you have a microservice system, you often see that there's this huge upfront cost of installing the right tools, and a good company would have like a Docker up and just running, but I've seen it all the times that there is quite some manual work involved in getting your microservice set up working. Where with a modular monolith, you can actually just install the project, maybe some dependencies you need to put them in, but you already get working with it. So it's way faster than your microservice design. And last but not least, it's a great setup in between the two extremes. So on the one hand, you have your good old monolith that's like a hell to work in with bigger projects. And on the other one, you have the microservice architecture that requires a lot of upfront design and a lot of knowledge to get working. And most companies actually jump between like, oh, we have a bad experience with a monolith, so let's go to microservices. And this pendulum goes back because, well, we now have a bad experience with microservices, so we move everything back to a monolith. But this is actually a really great step in between those two. So if we look at the productivity versus complexity chart again, we start the same with a monolith because we don't care about boundaries at the start. But as we notice that our productivity is going down, we might ask ourselves some questions like, okay, can we maybe now introduce some boundaries? And if the time is right, and if you really notice that, hey, my productivity is really off, that's the time you can start your context mapping, do your design, start your refactoring, and not really later after that, you actually refactored your monolith to a modular monolith. And this is combining best of both worlds because you have like your first, your speed to market, your validation of the ID, you can do that quickly. And once you have like the traction and the resources to fix it, you can refactor. And maybe down the line, you scale so much that a modular monolith isn't working for you anymore. And then it's really easy to actually grab one of the contexts, move them to their own microservices. And because you already have the same kind of communication patterns, it's not that big of a refactor to do. So even migrating from a modular monolith to microservices when the time is right is quite doable. So this was all I had to say. I want to thank you for your attention. You can find me on Twitter for questions, or I'll also be at the conference the upcoming few days. So yeah, please ask me any questions if you have some, and thanks for your attention.